Accelerated 7th graders. I wanted you guys to have a little extra practice with the scale drawings. So this is the video that goes along with the scale drawing presentation. So I was hoping that you would go through the presentation on your own, and the problems that don't have answers on the presentation slides, for you to figure out those on your own. And now I'm going to work them out so that you can make sure you have the right answer. So let me share my screen so we can look at those together. Alrighty. There we go. All right, so we are determining actual lengths from scale drawings. Hopefully you guys read this. So if you're using a scale drawing, you're taking an original and you're either making it larger or smaller. If your scale factor is more than 1, your image is going to be bigger. If your scale drawing or scale factor is less than 1, your image is going to be smaller than the original. You guys read through these. We can identify the scale factor by making a ratio. So you could either say that the scale drawing is 14 to 144, or the opposite, 144 to 18, and then you could simplify it. If you did 13.5 over 108 and simplified it, your ratios should match. 1/8. All right. Now, if it doesn't tell you specifically which is this original, if you got 8 over 1, if you said that the room is 8 times bigger than the blueprint, technically that is also correct. So if you're not given the original, you could flip that ratio and it would still be correct. All right, same thing, either 2 over 12, which is 1/6, or 12 over 2, which is the scale factor of 6, depending on which is the original. All right, you guys have already read this, so I'm going to just go to the problems that haven't been answered yet. But you do need to realize you can give scale factor in a fraction, you can give scale factor in decimal form, you can give scale factor in percentage form. All of those are acceptable. All right, cross multiplying and dividing is how we find the scale factor sometimes. It usually works. All right, so are these answered? Yes. So you could say that the model is 1/228 the size of the Statue of Liberty. Or to reverse that, you could say that the Statue of Liberty is 228 times greater than the model. All right, so here I think that's the first problem that isn't answered for you. So we are going to read this problem. It says, on a road map, the distance from Green Bay to Chicago is 11 centimeters. What is the actual distance between the cities if the map scale is 3 centimeters to 90 kilometers? Show your proportion. So I think it's going to let me draw up here on this other screen that you're not necessarily looking at, but all right, so we're going to make a proportion. So we have 2 different units going on. We have centimeters and kilometers. So I'm going to put 3 centimeters to 90 kilometers. Now, to me, it's easy if I use those units, because then when I set up my second ratio, I want to match. So if I have centimeters on the top of the first ratio, that 11 has to go on the top of the second ratio. And then what is the actual distance? Well, that's our unknown. That's our variable. So how do we solve proportions? We cross multiply and divide. So we're going to cross multiply. X times 3 is 3x. 90 times 11. 90 times 11. Whoops, I'm using my calculator. Is 990. And then how do I solve for x? I divide both sides by 3. So x is equal to 330. 330. 330 what? 330 kilometers. Okay. All right, the next one. So it says the scale of a map is 2 centimeters to 15 kilometers. Find the actual distances. So our first ratio is going to stay the same for all of them. So if these are all centimeters, they're going to go on the top of the second ratio. And we're figuring out what our kilometers are. So we're going to cross multiply. We do 2x is equal to 15 times 8 is 120. And then we divide both sides by 2. So 120 divided by 2 is 60. 60. All right, what if the centimeters was 1.3? So the first one stays the same. The second one, all we do is change our 8 centimeters to 1.3. So 1.3 goes here. So we're going to cross multiply 15 times 1.3, and then we're going to divide that by 2, and we get 9.75. And I should always label my units. 9.75 kilometers, 60 kilometers. And then finally, the last one is 24.4 kilometers. So I'm going to erase this. Use my pen. And now I have 24.4. So when I cross multiply, I get 24.4 times 15. And that number divided by 2 is 183 kilometers. 183 kilometers. Awesome. And then the last section, a scale drawing. A scale drawing has a scale of 1/2 an inch to 10 feet. So I don't like fractions. I don't use them unless I absolutely have to. So I'm going to change my 1/2 to 0.5 inches over 10 feet. We want to know the length on the drawing. So they give us the actual length. So these are feet. So since my 10 also is feet, I'm going to put 20 here. And I don't know my scale length. So we're going to cross multiply. So we're going to do 20 times 0.5, which is 10, and 10 divided by 10 is 1. So 1 what? 1 inch. All right, now instead of 20, we're going to use 15. So 15. So 15 times 0.5 is 7.5, and 7.5 divided by 10 is whatever 7.5. So that would be 0.75. 7.5 divided by 10 is 0.75. So 3/4 of an inch. And then finally, we use 45. Instead of 15, we're going to use 45. So 1/2 of 45, so 45 times 1/2 is 22.5, 22.5, and we're going to divide that by 10, which is 2.25. So 2.25 inches, 2.25 inches. Wow, guys, I really can write neat, but you'll never know from looking at my notes. All right, and so finally we have a picture, what looks like maybe a blueprint or a floor plan, and it tells us that each 2.5 centimeters on the scale drawing equals 5 feet. So what are the actual dimensions? So our first ratio is going to be the same for all of them. We're going to use 2.5 centimeters to 5 feet. Is equal to, well, these are all centimeters, right? So we're going to put the centimeters. on the top of both ratios. And our unknown is our feet. So we're going to cross multiply 5 times 1.2, and then we would divide that by 2.5, and we get 2.4. 2.4 what? 2.4 feet. And then 2.8 is going to end up being half of that, or double that. So it's going to be 5.6. Ooh, that was messy. 5.6 feet. And then this is going to be 8 centimeters. So hopefully you guys have tried these and now you're just checking your answers. This is going to be 8.8 feet. That should be feet. And then finally we have 11.2 feet. 11.2 feet. All right, sorry about my handwriting, it's atrocious. So then on this, this screen, it wants us to draw a new rectangle with a scale factor of 200%. So what does that mean? What is 200% equal to as a decimal? So move your decimal 2 places to the left, and we'll find a rectangle that's literally twice, which of course I have to eyeball it. I don't really know what's twice. But the new rectangle should be twice the size of the old one. And so this, instead of 15 centimeters, this is going to be 30 centimeters because we would multiply 15 times 2. So 200 is the same as 2.0. If this is 6 centimeters, double that would be 12 centimeters. All right, so they wanted to know the original area. So the original area was 15 times 6, which is 90 centimeters squared. Because centimeters times centimeters is centimeters squared. And then the perimeter would be 15 plus 15 plus 6 plus 6. And this is 42 centimeters. So let's see how the area, the new area and perimeter change. Do you think the area is going to be twice as big? Do you think this perimeter is going to be twice as big? Well, one of those things is true. So now for the new area, we're not multiplying 15 times 6, we're multiplying 30 times 12. So it's not twice as big, it's really 4 times bigger, because now the new area is 360 centimeters squared, which is 4 times 90, because we doubled both sides and then we multiplied. So it's not twice as big, it's 4 times bigger. Now the perimeter though wasn't multiplied, we were just adding numbers that were twice as big, so that will literally double. So the scale drawing, the scale factor affects the perimeter the same as the dimensions, but it affects the area. You'd have to square the scale factor, and that's how much bigger the new area will be. So the new perimeter is going to be 84 centimeters. 84 centimeters for the new perimeter. All right, we're almost done, guys. Oops. No, I didn't mean to do that. Discard. Oh man, I closed it. Let me just open it back real quick. All righty, go down to the last slide. Almost done. All right, one more. All right, so here we have rectangles. We're supposed to draw a new one. So with the scale factor is 120, is it going to be bigger or smaller? Well, it's going to be bigger because more than 100%. So we would draw our rectangle and we would label the dimensions. 8 times 1.2 would be 9.6. Oh, did it again, you guys. 9.6. So we have 9.6. Oh my goodness, this thing hates 9s. It thinks I'm making a circle. So I have to make awful looking 9s, 9.6. And then the side is 3 times 1.2. So it's a 9 by 6, which that doesn't look like a 9, by 3.6. So our original area was 24 inches squared. And our perimeter originally was 16 plus 6 is 22 inches. Our new area is 9.6 times 3.6, so that's 34.56 inches squared. And the perimeter is 22 times 1.2. The perimeter should be 26.4 inches. All right, what about this one? Is our picture going to be bigger or smaller? Well, it should be smaller because 5 times 0.6 is 3. So it's smaller. This is going to be 3. 2 times 0.6 is 1.2. Our original area was 10 feet squared. And our original perimeter was 14 feet. So our new area is going to be 3 times 1.2, which is 3.6 feet squared. And our new perimeter is going to be 8.4, which is crazy because you would think, oh, the area has to be bigger than the perimeter, but not always. Not always. All right, look at the next one. Is our rectangle going to be bigger or smaller than the original? The answer is smaller. So our original area is 96 centimeters squared, 96 centimeters squared. Our perimeter is plus 16, 40 centimeters. Our new dimensions are going to be 12 times 0.4 is 4.8. Our new width or length this way is going to be 3.2. Oops. 3. Oh my gosh, this thing hates circles and it thinks all of my round pretty numbers are circles. See, and I got to make ugly box. Oh my goodness. This is a 2. Okay, 30 or 3.2. 3.2. All right, so the new area is 4.8 times 3.2, which is 15.36. 15.36 centimeters squared. And the new perimeter is going to be what, 16? Yes, 16 centimeters, and this was centimeters squared. We're almost done. Now the last one is 3 times bigger, so obviously I don't have enough space to draw it 3 times bigger, but 7.5. So first our original area is 33.75. And the new area is going to be 9 times that. The scale factor is 3. So if you square 3 squared is 9. So the new area is going to be 9 times bigger than the original. So the new area is 303.75. Our original perimeter was 7.5 times 2 plus 4.5 times 2 is 24. And if that's 3 times bigger, it's going to be 72. So we didn't figure out our new dimensions. So 7.5 times 3 is 22.5, 22.5. And our other width is 13.5. So then hopefully when you check our answers on the bottom with these numbers, we'll get it right. So 22.5 times 13.5 is in fact 303.75. And then 22.5 doubled plus 13.5 doubled is in fact 72. So we are correct. All right, guys, so hopefully you all did well on this. This should be your second day on scale factor. I put the suggestions of the days that you do each math section. Of course, it is only a suggestion because you really get to determine your own schedule when you're doing virtual learning. But if you will follow my schedule, you'll be done with everything every Friday. So it's just up to you what you do. So everything's due by Sunday night, obviously. All right, guys. I will talk with you soon.